Hello, everyone. I'm Chris Marchbanks, and today I get to introduce our next talk. Here we have talking about K9P. Kubernetes is 9P files. We have Terin stock from Cloudflare. So please, everyone, welcome Terin, and let's enjoy the talk.
Thank you, Chris. I'm going to be talking today about K9P, which is a project I've been working off and on for the past couple of months. So Kubernetes as P9 files. I'll explain what that means as we get into it. But first, that's me. In the background is my new ride. I parked it just north of here. I'm a Kubernetes engineer at Cloudflare, and you can follow me at Terin Jokes on Twitter and GitHub. So let's think of a hypothetical system. What if we could orchestrate compute across multiple hosts, or orchestrate storage across multiple hosts, and run compute separate from users so they can work on their local machine, and the compute can run somewhere else. Those applications can run in a sandbox. They see their own processes. They see their own CPUs. They see their own files. They don't see other things that are running there. And there's a system for service discovery. Probably never heard of such a system before. That's why you came to KubeCon. But what if it was 1992? Linux 1.0 is still 2 years away. Process containers, what we now call C groups, is 14 years away. Let me container that for you. And Docker is 21 years. And Kubernetes wouldn't be open source for another 23 years. Well, way back then, we had a thing called Plan 9, which was a system designed around multiple machines computing single tasks, or rather, multiple machines doing multiple tasks, where you might have a workstation that's separate from a compute farm, that's separate from a storage, and they could all work together. And as much as I want to turn this into a papers we love, I've been told that I only have 35 minutes. So instead, I do recommend going and reading the Plan 9 papers. You'll find that a lot of it that they were thinking about in the early 90s is the same types of things that we're talking about here at this conference. But let's talk about K9P. K9P is Kubernetes exposed as a 9P file system. And my goal when I set out to start this was to make it easy to interact with Kubernetes. You can use familiar tools. If you are familiar on the command line, you can use ls, cat, vim. If you prefer graphical, you can use Finder, Windows Explorer, Nautilus. Or you can integrate it into other workflows you might already have that are file-based, and not really have to think about the fact that it is Kubernetes or learn kubectl behind the scenes. So what is 9P? 9P was a network file system, originally from Plan 9, that it was used all over the system. So the windows that were running on your screen were connected over P9. You can interact with them with P9. Network connections existed in a file system called NetFS, which you could interact with to make new connections to other systems. And the cool thing about these types of things, since they're a file system, you can mount them over the network. So if you want to build a proxy, all you do is connect to another machine and mount its NetFS, and then you can create new network connections as that machine. Look at processes, either your own processes, or if you've mounted another process file system, you can see those as well. You can see open files. The scroll back buffer in your terminal was available as a file system. So lots of things, everything was a file. And this was all done with about 14 RPC messages. These were designed to be remote. So all of these are asynchronous. They can happen. Preferably there's an order they happen in, but you might have multiple things happening on the file system at once. Compared to Fuse, which pretty much is a one-to-one map to the Linux file system interface, there's about 40 and counting. So there's a lot, and those are expected to be on the same machine. So there's a lot less to think about, and those also work remotely. What makes it kind of useful? P9 is still used in the modern era. You have DataKit and VPN Kit from Docker. You have VirtFS from Q. You have Windows Subsystem for Linux by Microsoft, and Crostini and gvisor by Google are all using P9 under the hood. Linux has native support if you compile a kernel with K9P, which most kernels from most distributions already are. And then you can just mount it as a 9P file system. Mac OS and Windows, the story is a little different. Both operating systems do have support for 9P internally to the operating system. Mac OS supports it starting in 10.14.4 when they launched their new Mac Pros, and you might actually run Mac OS virtualized. And as I said before, Windows supports it for Windows Subsystem for Linux. You can use Fuse implementations on both of those. So you can have a virtual file system for your virtual file system. So what are the types of things that I thought out to do, or thought out to deal with K9P when I started out? So everything is a file. All you have to know is your usual file tools. So if you want to see information about a deployment, you can do ls. And you can see the actual underlying YAML file, and then there's some other control files that are broken out that you might want to interact with. So like scale, or you look at the status directly. So if you want to scale up a deployment, you can write the number into the scale file, and it will scale up, hopefully. You can search for pods that are not running by looking at the status field, the status control file of different pods. And so if you grep for files that don't contain the word running, then you might find a pod that's not in the running state. You can tail logs across multiple pods by just running tail, and it will tell you what pods those came from, because it will be in the file name when it prints out the logs. And you can modify your resources by running sed or your favorite tools on top of the deployment YAML file. And then you might decide that you want to do even crazier things, like building a controller on top of this. So you can build it in your favorite language. You don't have to worry about there being a binding to Kubernetes, because everything's a file, and most tools have great, or most programming languages have great file system support. You don't have to have networking code in your controller. In fact, it doesn't even need networking access, because the client that has mounted the file system can be in a different network namespace. And it's very testable. Your inputs and your outputs are just files. So you know if it works, if it's written out the files that you expect, which makes it a great place for golden file testing. This is my demo. Maybe it will work. So let's see. We can run the server. I'm running it locally, but it can be run remotely. I don't think it logs anything first, because why would I do that? So here I'm using the Fuse version because I'm on Crostini on Chrome OS, and it doesn't let me mount 9P file systems, so I'll use the Fuse version. And I mounted it to the mount directory. So we do that. You can see we have cluster scoped resources and namespace scoped resources. So we can look at namespaces, see all the namespaces on the system. And likewise, we can look into specific deployments. I think there's kubedns here. So if we can look at how many instances there are, there's 2. And we can look at its representation. So my simple demo. I don't want to tempt fate too much. So how did I implement K9P? So the server is implemented in Go. That's my primary language. It exposes a 9P server over TCP, and it's using client Go under the hood so that it has great interactions with the Kubernetes API. Right now, each mount is associated with a new connection to Kubernetes. This is so that in the future, you can have multiple users connect with their own credentials, and you won't have a confused deputy problem. All the information will be contained to one mount. There's a lot of 9P implementations in Go, P9P from Docker, 9P, Sticks, and P9, which is the gvisor implementation. Unfortunately, each has a different level of implementation, a different abstraction you need to think about, different paradigms. I've decided to use P9P from Docker. I have implemented this in all four, and this is the one that felt like the most convenient and easiest to use. Kubernetes resources are mapped to directory layouts. So like I said, cluster scope resources are mapped to cluster. Namespace scope resources are mapped inside of namespaces. And each supported resource type has a handler implementation. I would like to derive this, so if it sees that there's a scale endpoint in the API, that it would automatically handle those types of resources. Right now, each resource type supports its own implementation. Some challenges. 9P has no polling. There's no way to do subscriptions. So this makes it difficult to tell the client that there's been changes to deployments or pods or anything after they've kind of opened the file. And so they can't do like an epoll select or anything that they might want to do. So hopefully we can work around this in some ways. So right now you're required to open the directory or file to observe changes. This is my first virtual file system. I continue to not be sure that I've chosen the right way of doing things. Internally, there's the clients give FIDs to each RPC message. So instead of a normal operating system where you give the process a file descriptor ID, in 9P, the client gives you the ID that it wants the file to be associated with. Those are mapped to resources. A lot of state is generated on demand. The performance isn't that great. I was actually surprised at how well it worked in this demo. But normally I've sat there for like 20 seconds after mounting it, going like, okay, where's all the files? The Kubernetes API uses resource versions to prevent modifications based on old versions of resources. It's kind of difficult to keep those in sync with what the user sees because of the lack of the polling mechanism. I would like to have a future improvement here to associate the resource ID with the FIDs and the planned INIDs to better tell the users when conflicts might happen. And when there are conflicts, the API is not great. You can only return errors to client request, but those errors are strings. Then there's no standard way that the clients interpret those strings. Some turn them into standard system errors, some print them out, some just turn them all into no-sys. So whether or not your clients will actually see the error messages you give back is up in the air. Authentication, I haven't implemented right now. 9P defers authentication to the implementations. So there's a file when you first connect that you can write to in exchange with the server any negotiated authentication protocol. Right now, I currently don't use this, so it just automatically accepts any connections. But in the future, I want to set up authentication protocol so you can exchange either your user or service tokens. So some discussion. This kind of only scratches the surface of what 9P can do. I do recommend trying out for fun. There's a lot of great project ideas on GitHub where people have played around with 9P. It'd be cool to have KubeCon talks as a file system, so you don't have to navigate YouTube. If you're interested in this but don't really care about files, you care about blocks, there's NBD, which is Network Block Device, which has a similar idea where you have an RPC message for block devices, which I think actually even has less RPCs than the 9P, so it's pretty easy to implement. And then you can make block devices appear out of nowhere. And queues allows you to build character devices. So you can build support for old devices in user space rather than having to upstream Linux kernel drivers. So I do recommend checking those out as well. If you like this project but want to do even more things with it, such as mounting GKE or Google Cloud or AWS as files, Puppet has Wash, which is a shell for interacting with remote and cloud-native infrastructure with Unix-like tools. And some of those things are exposed in a Fuse file system that it also has. So do recommend checking that out. There's some questions about the future of 9P. The protocol uses strings for UIDs and GIDs. That didn't catch on most other places. They like to use numbers. So those get mapped in weird ways by different systems. There's lack of support for things that you might expect from a modern Linux system. Symlinks sometimes work, sometimes not. And whether or not you can do relative symlinks or they have to be absolute depends on the client. And things like X-adders, sockets, name, FIFOs, everything that you might expect to exist on a file system, some of those just can't be represented. The protocol is versioned and can be extended, but Bell Labs isn't really a thing anymore. So the question is, who's coordinating that? If you look at the gvisor implementation, I think there's 8 versions that they've put on top of things that only the gvisor implementation or likely internal Google 9P clients know about. So maybe those things can be used in other places, but who knows? We can negotiate versions, but there's no standard on what those versions are. So use at your own risk. It might delete something important. This is my hobby project. The license says that there's no warranty. I would be surprised if it deletes things because I didn't implement remove. But it might. You can learn more at terin.e/u/K9P. And I think I have some time for questions. And if you have other ones after that, I'll be available in the hallway track. Yes. I don't know how we're doing this. Oh, we're going to make Chris run around.
Was it? So this is really interesting. I'm curious, like, what are some of the riskiest things that you've done with this? So I noticed when you open your terminal, you have like, it told you about like a Git branch, and I thought for a second that you had it source controlled, and I was really confused about how that might work. So it made me want to ask, like, what have you tried to do that's totally wild?
Yeah, the source control and the shell was just me being checked out into the Git repo for the project. I don't know if I've done too many risky things. I think the early projects early implementations I did have remove and move and things like that implemented. But those were against like test clusters, so not too many risky things. I'm sure now that it's out in the world, people will do things and I'll get fun bug reports. Yeah.
Hi, why not just use Fuse?
The idea here was, well, Fuse mostly, you're running the implementation on your local system. With the idea here, I wanted to move a lot of that mapping to a central server so that you could run that mapping in Kubernetes itself and then clients could just connect rather than each client having to have its own implementation of all that stuff.
Okay, one other small question. With the file system interface, you mentioned about parsing errors and all that. How would you think we can better propagate errors through the file system API to the user if they're using the file system?
Right now, if you look at like the Linux implementation, it does a string search based on the strings that you've sent back. So maybe if we can get that codified so that various implementations can use those same strings, or maybe have a different, negotiate a different version of 9Ps where we can return numbers. So like gvisors implementation, if you negotiate a certain version, instead of giving back strings, it will give back IDs for files, for the user IDs and group IDs.
And do you support Kubernetes events because they are on transient, right?
Sorry?
Did you support Kubernetes events as files?
If I understood correctly, do I support events? Not yet, but it's just another resource type that can be implemented. I think we have another one up here, Chris.
Hey, cool project. That's awesome. Have you ever tried to move something from one cluster to another to see what happens?
I've not yet, but there is the canonical YAML file. So in theory, you could use that to move things. Yeah, I guess you'd probably want to strip out self-links and stuff like that.
One question is when do you plan on implementing the volume plugin for this?
Sorry, what was that? It's like a CSI volume. I thought about that over the weekend in the fear that people were coming to this talk expecting that, but then I didn't actually do it. So yeah, 9P CSI soon.
Great project. And simple question, what is the main advantage of API as files? So why not we don't just use REST-based HTTP API? You mentioned one of the advantages is the ease of implementation of operators or some kind of stuff, but HTTP is also very flexible and great API, and most languages have support for HTTP. And so, what is a major advantage API as files?
I wouldn't say there's a major advantage. I mean, REST is a very similar idea, just your RPCs are structured differently, but you still have create, delete, update. So it's a very similar idea. You could turn a REST API into a file system probably fairly easily. And I think I've seen Fuse file systems that do that. The main advantage here was that I wanted to put things in a isolated namespace that didn't have network access, but could still interact with Kubernetes, which to use a REST API directly in that project would require having network access.
Okay, what else?
How would you handle CRDs in Kube cluster? I know you mentioned you needed a different implementation for each resource type. Have you given much thought to how you might handle that?
I've thought about, as I mentioned, things like scale that could reasonably be abstracted across many different types. I know KubeVirt has scale endpoints on replica sets. So if I had implemented that, that would already work. Otherwise, it might just be like a standard a standard implementation just for unimplemented resource types. So you'd still get maybe status, labels, and the YAML format, but not have any fancier things.
Just curious, did you think about file permissions as Kubernetes access control?
Right now, I don't do any of the RBAC stuff. It just relies on when you do lookups or you make changes, does the Kubernetes API server reject that? I could implement that things so that when you do an LS, you can see the correct permissions, but I haven't implemented that. Right now, it just says you have read-write to things.
Hey, so you showed the scale endpoint and you showed reading the YAML file, but if you were to edit that YAML and write it, would it update the cluster resource?
Right now, in the version that's open source, no. In a different version that I had in one of the other implementations it did. My goal is to get that done soon.
What else? Any other hands?
I love the idea. This is phenomenal. I'm kind of curious, how much time did it take you to put together maybe your first prototype and where you are today?
I think my first prototype was 2 weeks. Part of that was notes for myself. I have a 9-page Google Doc of just notes of other projects I've seen, or when you read a directory, it expects the last read to return 0 bytes, and things like that. All in all, I've been working on and off since about May or so, but I haven't tracked the number of hours.
Okay, what else? Am I missing any hands?
Yeah, I think we have another one here. Oh, 2 more.
2 more, so up front.
So you mentioned authentication could be improved. Are you saying that the session tokens are just persisted as files even after you use them for that one session? Is that the issue?
Right now, the server has the authentication. When you start up the server, you point it to kubeconfig. In the future, I want to move that so that the clients have to provide the authentication, so that each one would only have the permissions that it would actually normally have. But yeah, that would persist for that session. And then when you unmount it, that session goes away.
Would iNotify work on this?
It does not. I think because of the lack of polling, there's no good way to implement iNotify.
Sorry. Even with kernel K9, P9?
Yeah, it just returns an error if you try to. You have a similar problem with other virtual file systems in Linux, like proc. You often can't do an iNotify there, even if you really wanted to know when that process opened a new file descriptor. I've run into that before.
All right. More questions?
Going once.
All right, great. Well, thank you, Terin.
Thank you.